Good morning, everyone. Now let's discuss together volumes of prisms and cylinders. First of all, why do we combine prisms and cylinders? Because in both of them here we have two faces or two bases, sorry, and the lateral faces are rectangle. Even here in the cylinder we can't consider it, but actually only the connection between them, that here I have two bases, as you can see here I have, this is my cylinder, so here I have those two are bases. And also here if I have here a cube, for example, so I have here two bases, as you can see. Generally the lateral faces are rectangles. The lateral faces are rectangles. Okay, he asks you here, for example, how are the volumes of two different stacks of index cards related? If you have seen this before, I think you've dealt with this one before. Here you have this like rectangular prism. This one is a rectangular prism. And here, if you just pay attention, that the angle here is a right angle. Okay, so that means here we have a a rectangular prism. The volume for this one, the volume here, is it exactly equal to the volume here if I have it an oblique? Yes, it's going to be the same. Why? Because we have the same basis. Okay, we have here the same basis, and also in the same time, each each intersectional part are congruent. So the volume for this one and that one will be same. So each index card has the same area and represents the same rectangle or cross section of the prism. So that means this one, the volume here exactly equals the volume there. What is the difference between right prism and oblique prism? The right prism here, the oblique prism, no. The right prism here, that I have here, all the lateral faces are rectangles, as you can see, but here the lateral faces all here are not rectangle or are non-rectangles. As you can see here, I have kind of parallelogram. So the volume of two stacks, or the volume, sorry, of the two stacks are same because the sums of the areas of the cards are same. We still have the same volume. Okay, so here he asks you, do you think the right and oblique cylinders have the same height? And they have also the same height and cross-sectional area also have equal volumes? Do you think that this one also equal? Yes. Why? So we are going to write here, yes. Why they are equal? Because actually we have the index card, the index here card, for example, if it's index card, or here circular instead, right? Circular instead of the rectangles, right? Instead of here, instead of rectangles. So we can just apply here. He said we have the same basis, we have the same height, we have the same cross-sectional area for each single bar. So that means we can just say here the same here principle would apply. The same principle would apply. Okay, why? Because already we have, or we satisfied all of the conditions, same area, same height, and same cross-sectional in each. Okay, let's continue here, and we will have like a general. If we have different bases now, but actually the area of the base are congruent, I mean the area for this square exactly equal the area here for this triangle, exactly equal the area for this circle. So Cavalier's principle states that if two three-dimensional figures have the same height and same cross-sectional area, I mean here for each single part at every level, then they have the same volume. So no need even to have the same shape, I mean, but we have only to have the same area. We have to have the same area. So the conditions here are what? Same height, same cross-sectional area at every level, and we have here same, which is here the same thing. Okay, so we have same height. As you can see, this is the same height, and also we have same cross-sectional area at every level. So this is the second part, then they will have the same volume. the same thing here, but here how can I memorize the formula? So it's easy for you here just to memorize. Imagine if this one is a swimming pool and I want to fill it in with the water. So what should I do? I'm gonna repeat the area. I'm gonna repeat here the area for the base until I finish the height. So the area of the base times the height. So if I have it, for example, here, this one is rectangular one. So it's going to be what? Length times width times height. If it's a square, so instead we will have here s square times height, okay? If it's here the area of the base, what's the meaning of this capital? That means this is the area of the base, area of the base. Okay, this is the meaning. If I have it as a triangular one, so it's going to be half B, which is the base of triangle, height of triangle times the height of what? Of the prism itself. Okay, just try to distinguish between the cases. If we have here cylinder, so the area of the base here is pi r squared times the height, which is actually the same rule that we discussed in the previous time. Okay, see here, Lonizel needs to store 20 feet cube. So what is the given here? As long as you have here cube, so that means I give you here the volume. I give you here the volume. So the volume here is going to be 20 feet cube. Okay, so this is actually the one that I want to store inside this one. Sorry, I'm so sorry. Okay, so this is actually what I want to store there. Okay, this is actually she wants to store this this amount of firewood. Could she use or could he use the storage rack shown? So first of all, here we are going to ask ourselves what kind of shape this one. It's kind of prism. Where is my base? Is it the rectangle or the triangle? You have to pay attention that the base here is your triangle, not the rectangle. Why? Because those here I have from them, I have two. The bases always are two. And here the faces or the lateral faces are rectangles. So pay attention from the shape. The base here is this triangle. So the volume for this prism, for this rack, okay, I mean volume of rack equals half B for triangle, H for triangle times height of what? Prism, right? The whole thing here, pay attention again, this is B. Okay, this is B, the area of the base. Okay, this is the area of the base. Clear? Let's move on here and we are going to substitute in this case. For how we are going to substitute, it's going to be here half times B, which is here base of that triangle, which is 6 times the height of the triangle, which is 4, times the height of the prism, which is here 2. Okay, so it's going to be here 24 feet cube. Can we store or can Lonzabel or Lonizel store? Yes, he can. Why? Because actually she needs or he needs only 20 feet cube, but she or he could store 24 feet cube. Okay, so could she store? Yes, or could he store? Yes, they can or he can store in this rack. Okay, continue here. Kensha here deciding between, or she's trying to decide between two here, between the two canisters or canisters, sorry. So, which canister holds more? What is the volume of the larger canister? Okay, so see here, as you can see here, I have like a right cylinder, and here I have oblique one, right? Here the height for both is 25, as you can see, and the area of the base will be same. If you still remember Cavalier's principle says what? If we have same height, same cross-sectional area for each layer, so that means we will have the same volume. Okay, so if you just evaluate either for this one or for that one, actually the volume will be same for both. Why? Is same here. Why here they are same? Because here we have same height as we have here same height, right? and also we have same cross-sectional area here for each level, right? For each level. So in this case, I can just say here that they have same area, so I can just evaluate for this one, the green one. So the volume here of cylinder equals here by r square, which is the area of the base, right? This is the area of the base times the height, right? So by r square, the whole diameter here is 20, so that means half of it is going to be 10. So 10 square times by times the height, which is here 25. Calculated, it's going to be what? It's going to be 7,854 centimeter cube, which is my final answer. Okay, let me move on here and sorry. Let's move on here and we will have another case. Okay, he asks you how would the volume of the storage shed change if the length of the triangular base is reduced by half. Actually, here in those questions or this kind of question, you are going to say like this. If he asks you about what triangular prism, right? So here, what is the volume? Okay, of a triangular prism, the normal one, triangular prism. Okay, the normal one. The rule says what? We said here the area of the base. What is the shape of the base? It's a triangle. So half base of the triangle times height of the triangle times height of the prism. Right? He said if the length of the triangular base is reduced by half. So this is the original one. And now I'm gonna change or like kind of a fiction here of what. So now the base of the triangle equals the half of this, the new one, okay? Equals the half of what? Of the old base of triangle, right? Substitute here in the previous one. Let's substitute together. So it's going to be what? See here? So here the new volume will be what? Will be here half times half times BH, which is here. I'm going to come back to the same color just to see here what is the difference between this one and the previous one. So I'm going to just change this one, half B of triangle, okay, I mean the base of the triangle times, let's continue here, H of triangle times H of prism, which is here basically, if you just pay attention here, what happened? Actually, I have it in the old one, right? Base of the triangle, I have it. Height of the triangle, I have it. Height of the prism, I have. So the only extra part here that we have outside. So we can just say here that the volume is what? What's the difference between the new formula and the old one? The volume here would be reduced by half. The volume would be reduced by half. Right? Okay, let's apply the same thing that we've done together, but how would the volume of canisters, change if the diameter is doubled? So what shall I do here? See, diameter here, he give you something like this. This is 2A, and now here this is 2B. Okay, here I will find the volume of what? Of cylinder. Equals what? By r squared times height, right? Now actually he gave me like a change on the diameter, so I will write this formula but using diameter. D here equals 2r, right? So that means r itself equals d over 2. So I will take it and substitute it there. So it's gonna be what? So it's gonna be here d over 2 squared times y times height. D squared over 2 squared, which is 4 by h. Right? This is the formula. This is the old one. The new change here, he said what? Diameter, I mean new diameter will be here doubled. I mean 2 times the old one. Okay, so the volume here will be what? Volume of the new cylinder. Equals what? Now volume of the new cylinder equals here equals by, right? Instead here I have d squared over 2, so I will write here instead of d I will write here 2d, right? So it's going to be something like this. We want to write it with respect to height. So it's going to be here 2d over 2, the whole thing here squared, right? Times height. 2 and 2 has gone, so now I will have by d squared times h. What is the main difference between this formula and the old one? If you just pay attention, here I have by, there I have by, right? I have here h, I have there h, right? I have here d squared, I have there d squared. So what is the main difference? That there I have 1 over 4, but here I don't have. So that means we remove the 4. Basically here we change the 4 by somehow. So we can just write here that the volume would, would increase by 2. Or sorry, by factor of 4. The volume would increase by a factor of 4. So we have here to write the volume, would increase here by 4. Okay, finish. I hope that it's clear for you. Let's continue here. He said Martha is repurposing a sandbox as a garden and is buying like the soil from her school's fundraiser. Estimate the number of bags she would buy or she should buy. As you can see, this is the sand box, or this is the garden, and she is gonna buy here soil or soil bag, as you can see, and we want to know the number of bags she should buy. So what are we going to do? See here, what are we going to do? Yes, see here, what are we going to do? We are going to find the area here, for example, the volume for the garden. So the volume of the garden equals here, pay attention from the units. Here I have inch, here I have feet, here I have feet, inches, right? So that means it's better here for us to change 4. So 4 times what here to change? 1 feet equals what? 1 foot, 1 foot equals here what? Equals 12 inches, right? So I will multiply here 4 times 12, which is here 24. Okay, it's going to be here 24. 4 times 12 equals here 2 times 4. It's sorry, here I just wrote the number by mistake. Sorry, I'm so sorry. Okay, so 2 times 4 it's 8, 1 times 4 is 4, 48, and also here 48. Okay, so now I will just multiply length times width times height equals what? Length times width times height equals, I just want to, yes, equals here 10 times 48 times 48 equals finally 23,040 inches cubed. Okay, So now I want to know here the volume of the soil bag here equals what? Length times width times height, which is here again 10 times 5 times 18. Okay, so it will be here. It will be here 5 times 18. 5 times 50. 5 times 18 here. It's going to be 900 inches cube. Now I want here to know the number of the bags. So number of the bags. The number of the bags here is going to be 23,440 divided by 900 equals divided by 900 equals 26 bags equals 26 bags. Okay, so now I got 26 almost. Hope it's clear for now. Let's move on. And if I have this question, how can I solve it? Catherine is using cans of juice to fill a cylinder pitcher that is 11 inches tall and has a radius of 4 inches. Each can of juice is 6 inches tall. What is the radius of 2 inches? How many cans of juice will Catherine need? Okay, so at the beginning here we have cylinder pitcher, right? And he said the cylinder pitcher, so I will just write here volume of cylindrical here pitcher equals, he said it's a cylinder, so by r squared times height by r, which is here 4 squared times height, which is 11. So you will find it using your calculator. Now the volume of can, the volume of the can. Okay, so it's gonna be here also by, and he said the radius is 2 squared times height. Find it please. After this, we want to know how many cans. So the number here of cans will be what? Will be here 4 squared times 11 times by over 4 times by times h. Okay, after you calculate it using your calculator, you will reach to that you need 8 cans. Hopefully it's clear for you now. Now, he said Benito has like 5 neons or 15 neons, sorry, tetras in his aquarium. Each neon tetra requires at least 2 gallons of water. What is the maximum number of neon tetras that Benito should have in this or in her aquarium? Okay, so what shall I do here? We are gonna find X1, the volume of the big aquarium, X1. Then we will find what? And also here, pay attention that the gallon equals 231 inches. Okay, so pay attention that I'm gonna use that one. Okay, so here how can I solve it? I will find here the area. Sorry, I mean the volume. Volume here of aquarium equals 8 square times by times the height, which is 32. Okay, which is here 32. So if you just calculate it, it's going to be 6,343. Okay, 6,333. Okay, the volume here of the water in gallon if it was, sorry, in gallons. Okay, so what will I do here? First of all, I will find here the volume in inches, okay, or in gallons, sorry. So I will just use this one. So it's gonna be 6,000. Just a second. 6,343 divided by what? He said. Excellent. Here divided by 231, which is okay. So if you just divide, it's gonna be here 0.5 tetra for what? For each gallon. Okay. Here we found the tetra in gallon. Compute the number of neon tetras that we need to should hold multiply by the number of gallons by multiply the number of gallons here equivalent by the density of gases as gallon. Okay, or tetra. After this, you will find how many. When you divide it here, it's gonna be what here? 27 approximately. It's gonna be 27.85 gallons. Okay, it's gonna be 85 gallons, as you can see. I hope it's clear for you now. Please start or try to solve this question. And when you finish, if the final answer equals 9, so that means you are in the right way. Thank you very much. Have a nice day. Bye bye.